दाबला बाप काय वाले
इंडस्ट्री में आ जाएगा
यांनी बोला तो होंगे रे बंद करायचं
मैंने में ये काटते हैं
बंद होते आणि इंडस्ट्री मात्र दाबला
तो लास्ट लगा होते हैं
बोला मग तेच एंडिंग
आता गोष्ट एकच झाली Hello, everyone.
2 मिनिट थांब माझं जाय म्हणजे कोण जाय म्हणून मिस 2 वर्ष थांब 2 मिनिट 2 मिनिट थांब
Hello, everyone. Warm welcome to our channel Acharya Mathematics. My name is Gopal Rao GN. My qualification is MSc, MPhil, B.Ed. I am having 30 years of experience in teaching. Now I am working as a HOD of mathematics in first grade college. Once again, you are welcome to class 12. Hello. Hello. Akasha.
आकाश पप्पा बोल रहे हैं देखो
Hello. Once again, you are welcome to class 12. Let us we start a fresh chapter, matrices. The chapter is simple and easy, and also the chapter is very important in the point of examination view. If you are not subscribed my channel, please subscribe and share your friends. Before going to discuss the syllabus, let us we reveal introduction. The term matrix was introduced by English mathematician James Sylvester, and it was developed by his friend Arthur Cayley. The knowledge of matrices is necessary in various branches of mathematics. Matrices are one of the most powerful tools in mathematics. Matrices simplifies our work to a great extent when compared with other straightforward methods. Matrix notation and operations are used in electronic spreadsheet program for personal computer. Matrices are used in the field of business and science. Matrices also used in cryptography. I hope this is enough brief introduction about matrices. So here matrices is a plural form of matrix, the word matrix, whereas matrix is a singular form, matrices is a plural form. Let us see what is matrix. So roughly we speak that matrix is a store of information of numerals. To understand this, let us we take an example. Suppose we wish to express the information that Anil has 10 pens. Anil has 10 pens. And Anil has 10 pens. We may express it as in this expression. So, with understanding that the number 10 inside the bracket represents the number of pens Anil has. Now, if we have to express that Anil has 10 pens, Anil has 10 pens and 5 pencils. 5 pencils. We may express it as with understanding that the first number represents number of pens possessed by Anil. The second number indicates that number of pencils having Anil. Suppose we wish to express the information that the number of pens and pencils having Anil and other is two friends, Amar and Ajay. So Anil has 10 pens and 5 pencils. Amar has 8 pens, 4 pencils. Ajay has 6 pens and 3 pencils. So this is expressed as 10, 5, 8, 4, 6, 3. So the numbers along the horizontal line constitute 10, 5 called rows. Here 10, 5, the numbers 10, 5 called rows. The numbers constitute along the horizontally, that is 8, 4 is again called row. 6, 3 again called row. So this is we called as row number 1, row number 2, row number 3, first row, second row, third row. The numbers constitute vertically, that is 10, 8, 6 called first column, that is first column. 5, 4, 6, 5, 4, 3 called second column, that is called second column. This is first column and second column. So here 10, 5 indicates that number of pens and pencils possessed by Anil. 8 second row, 8, 4 represents number of pens and pencils possessed by Amar. Third row 6, 3 represents number of pens and pencils possessed by Ajay. So at the same time 10, 8, 6 the first column indicates that number of pens possessed by Anil, Amar and Ajay respectively. 5, 4, 3 represents the number of pencils. Number of pencils 5, 4, 3 having Anil, Amar, Ajay respectively. Okay. I hope you got it. So here 10, 5. 10, 5 indicates the number of pencils, number of pens and pencils possessed by Anil. 8, 4 represents number of pens and pencils possessed by Amar. 6 and 3 represent the number of pens and pencils possessed by Ajay. This expression can also be write it as like this: 10, 5, 8, 4, 6, 3. The first column, here we have 2 rows and 3 columns. 3 columns. Here, first row 10, 8, 6 indicates that number of pens possessed by Anil, Amar, Ajay respectively. Second row 5, 4, 3 indicates that number of pencils possessed by Anil, Amar, Ajay respectively. So it means that this is the store of information. We can store the information in our convenient way. Either we can express in this form or in this form. But here, what you are got it here, matrix is only the store of information. So I mean that matrix is the display of numbers. Matrix is the display of numbers. Now let us come to the definition of matrix. I hope all of you got it. Yes or no? Now let us come to the definition of matrix. So here we define matrix. Definition of matrix. Matrix is an ordered array of numbers or functions. Matrix is an ordered array of numbers or functions. So here array means arrangement. So matrix is an arrangement of numbers or functions in rows and columns. So this is the definition of matrix. Okay. So here, suppose I am having number 1, 2, 3 like this. The number. So this number is next 4, 5, 6. This is the arrangement of numbers. Is it right? So here these numbers are enclosed by the ordinary bracket or closed brackets. We can use the symbols brackets, either ordinary bracket, parentheses or square bracket. Got it? All of you understood? Okay. Next, here usually the matrices are denoted by uppercase letter that is capital A, capital B, capital C, capital X, capital Y, etc. Okay. Now let us see the example here. A equals 10, 5, 8, 4, 6, 3. So it is a matrix. The numbers inside the bracket are called elements of the matrix or entries of the matrix. Elements or entries of the matrix. Okay. Next here I take one more example, B, that is 1, 2, 3, like this. This is also a matrix. This is also matrix arrangement of numbers or functions in rows and columns. We take one more example, that is C equals. So here I take it as sin x cos x minus cos x sin x. Here sin x and cos x are functions. So here A, B, C are example for matrices. Now let us discuss important concept, that is order of a matrix. Order of a matrix. So here to define order of matrix, first we focus on the number of columns and number of rows present in the matrix. First we focus on the number of rows. For example, here in the matrix A, we have how many rows are there? 10, 5 is a row number 1, 8, 4 that is a row 2, 6, 3 row 3, means this matrix has 3 rows. Okay, this matrix has 3 rows and how many columns? 10, 8, 6 is column 1, 5, 4, 3 is column 5, 4, 3 is a column 2. So matrix A is said to be order is 3 by 2. I hope all of you got it. Is it not? Yes or no? So here order of a matrix means number of rows into number of columns. Means here we read it as number of 3 by 2. Got it here? Next we come to the another example, B. So B is a matrix. So first you count the number of rows. 1 is a row, 2 is the second row, 3 is the third row. Is it right? This is row number 1, row number 2, row number 3. This is R1, R2, R3. So in this matrix we have 3 rows and we have only one column. Therefore we say that order of the matrix B is 3 by 1. Okay, got it? Next, when we come to this example C, so first we have to, what we have to do here? First we have to count the number of rows present in the matrix. So here sin x cos x is one row, minus cos x sin x is second row. So in this matrix we have 2 rows. The first number always indicate the number of rows. Next, what to do here? We have to count the number of columns. Sin x minus cos x is column 1. Cos x sin x is second column. That is, there are 2 columns. So here in this matrix we have 2 rows and 2 columns. 2 rows and 2 columns. So we say that order of the matrix C is 2 into 2. We read it as 2 by 2. Here order of the matrix A is 3 by 2. Order of the matrix B is 3 3 by 1. Here, next, observe here one important, we notice that here matrix means arrangement of numbers in rows and columns. We know it. Okay. So here next I am going to say that just to count how many numbers or how many entries are there in the matrix. Here 10, 1, 2, 3, 4, 5, 6. I mean that the matrix A has 6 entries. The matrix A has 6 entries. Is it right? That 6 is equal to product of the number of rows into number of columns. That is 6 is equal to 3 into 2. I hope all of you got it. Is it right? Okay. Next, when we come to the example, second example, B is a matrix. You just count the number of entries are there in the matrix. 1, 2, 3. There are 3 entries are there. I mean 3 elements are there. Okay. Here that 3 is equal to product of the number of rows into number of columns. Yes or no? That is 3 is equal to 3 into 1. Next, when we come to the matrix C, again you count the number of entries in the matrix C. 1, 2, 3, 4. There are 4 entries are there, or 4 elements are there. That 4 is equal to number of rows into number of column. That is 2 into 2. That is equal to 4. So here, what you have to concentrate here, number of elements in the matrix is equal to product of the number of rows into number of columns. I hope all of you got it. Is it right? So this is the definition of order of matrix. Now we come to the in general form. Suppose, see here, next we see the position of an element. Position of an element in a matrix. Position of an element in a matrix. Here I consider the matrix A equals 10, 5, 8, 4, 6, 3. Okay. So here position of an element means in what is the position of 10 in this matrix. Position means in which row and in which column the matrix 10 lies. Got it or not? here element 10 lies in the first row. Is it right? First row and first column. Okay, so hence we say that a position of an element 10 in the matrix A, we symbolically write it as like this: A11. A means general element. That is the first. Here we use two suffixes. First suffix indicates the number of rows. Second suffix indicates the number of columns. So position of an element 10 is A11. Next, we take 5. So actually we have to find in which column and which row it lies. The 5 is an element lies in the first row and second column. First row, second column. Is it right? So we generally represented by A12. A12 is the element. A12 represents the position of an element of first row, second column. Okay, next here we take 8. To find the position of 8, first you have to focus on which row 8 lies. This is second row. Okay, this is second row and first column. Second row and first column. Therefore 8 is denoted by A21. Okay, next 4. The number 4 lies in the second row, second column. So that is R2C2. So 4 is represented by A22. Next, here we see that 6 lies in the third row. Yes or no? Third row, first column. This is the third row. This is the first row, second row, third row. I am now observing element 6. 6 lies in the third row, first column. Again 3 lies in the third row, second column. So 6 is represented by generally, that is A. This is third row, first column, A31. Next, here 3 is represented by generally A32. This is the identification of position of elements in the matrix. This is very important concept. Okay, got it here. Okay, so here to identify the position of element, we focus element in which lies in the rows and columns. In which rows and in which column lies. That is the coincidence of rows and column is the considered as position of an element. Okay, so this is order of a matrix. After that, we move to the one important concept, that is we generally we write it as matrix. So generally the matrix we write it as like this: A11 means first row, first column, first row, second column, first row, third column, and so on. First row, nth column. Next, this is second row, first column, second row, second column, second row, third column element, so on. Second row, nth column element. Next, I take it as m rows, that is am1 means mth row first column, am2 mth row second column, am3 so on, amn. Is it right? So here this is said to be a general matrix. This is said to be a general matrix. A. So this matrix in compact form we write it as like this. A equals Aij. In compact form like this. So the first suffix I represents the number of rows. Second suffix j represents number of columns. Okay, let us see here I. So how many rows are there? Here m rows are there. I mean that it may be lying between 1 to m. J number of columns, first column, second column, third column, that is 1 is less than equal to j is less than equal to n. Okay, so where I and j are numbers, that is natural numbers. This is the representation of a general matrix. Next, just we come to the analytical geometry. In a coordinate plane, every point is identified by ordered pair of numbers x comma y. Is it right? So here in matrix form, here this we can represent a point in a matrix form, that is x y like this, or we write like this also. Okay, here suppose that let A, B, C be a triangle with vertices A equals 0, 0, B equals 0, 6, C equals 10, 0. Here the coordinates of a triangle, coordinates of a triangle may be represented in a matrix, that is 0, 0, 0, 6, 10, 0, or we can write it as 0, 0, 0, 6, 10, 0. In the beginning I have told you that only matrix is only the representation of numbers or display of numbers in our convenient form. But in this matrix here, first row indicates the x and y coordinates of a point A. 0, 6 represents coordinates x and y coordinates point B. 10, 0 represent coordinates of a point C. Yes or no? Whereas in this matrix, the first column represents coordinates of a point A, x and y coordinate point A. Second column represents x and y coordinates of a point B. 10, 0 represents coordinates of a point C. With this knowledge, let us be moved to the types of matrices. types of matrices. So here we discuss first one is column matrix. Second one is row matrix. Third one is square matrix. Fourth one is diagonal matrix. Diagonal matrix. Next one is scalar matrix. Next one is identity matrix or unit matrix. Last one, null matrix. Null matrix. Here we discuss one by one. First, let us we discuss column matrix. Column matrix. Definition is very simple. A matrix is said to be column matrix if it has only one column. Got it here? Only one column. It has only one column. That is 3, 4, 5 is a matrix. Is it right? 3, 4, 5 is a matrix. So in this matrix we have only one column. But you need not to find out the number of rows. Okay. Here we have 3 rows. One row, second row, third row. But column is only one column. Okay. Hence it is example for column matrix. So next one more example, that is 0 minus 3. 0 minus 3. So in this matrix also we have only one column. These are two examples for column matrices. Then what is the order? Here, how many rows? When we define order, we have to focus the number of rows and number of columns. Here we have one row 2, row 3. There are 3 rows, yes or no? And only one column. The order of the matrix is 3 into 1. Here order of the matrix is rows to column 1. That is 2 into 1. Okay, got it here? Then generally we define like this. Let A is equal to Aij be a matrix. Aij be a matrix. Okay. Then I represent the number of rows. J represent the number of columns. Is it right? Then here number of rows may be any number of rows. Okay. But column should be always 1. Therefore, Aij m cross 1. M cross 1 means number of, there are m rows, only one column. This is the general definition of column matrix. Okay. Next, let us come to the row matrix. Row matrix means a matrix is said to be row matrix if it has only one row. Only one row. That is 4, 5, 6, 7. So here 4, 5, 6, 7. This is a matrix. So in this matrix we have only one row. Means here the numbers constitute along only one horizontal line. This is only one row. Okay. So this is example for row matrix. You take one more example, that is half 7. Half 7. This is also an example for row matrix. A matrix is said to be row matrix if it has only one row. Next, now we define order of a matrix. What I have told that here to define order of matrix, we need to focus on the number of rows first and then number of columns. Here how many rows are there? only one row. Number of columns, this is the column 1, column 2, this is column 1, this is column 2, column 3, column 4. So 1 into 4. Next, so in this matrix, to define order, first you have to count the number of rows. There is only one row. Only one row. Next, column, one column, column 2. This is 1 cross 2. Order is 1 cross 2, or we say 1 by 2. Okay. Next, can you define a general row matrix? General row matrix means you write let A equals Aij is a matrix. A is a matrix. So in this matrix, I represent the number of rows, J number of columns. In the row matrix, it may has any number of columns, okay, but row should be always 1. Therefore, we write 1 into m. This is a general definition of row matrix. I hope all of you got it. Is it right? Next, we come to the square matrix. Next, we define a square matrix. Square matrix. A matrix is said to be square matrix. The number of rows are equal to the number of columns is said to be square matrix. Here, a matrix is said to be square matrix if the number of rows is equal to number of columns. Is it right? So here I take example 2, 3, 4, 1, minus 2, 7, 6, 9, 8. So here this is the matrix. This is a matrix. Here how many rows are there? This is row 1, row 2, row 3. There are 3 rows. How many columns are there? Column 1, column 2, column 3. So it has 3 rows and 3 columns. Okay. So here this is example for square matrix. Okay. Next you take one more example, that is 4, 7 minus 8 root 2. Okay. So here 2 rows are there, 2 columns are there. Order is 2 by 2. This is represented by B. This is also example for square matrix. Next, you take one more example C, that is I take it just write only one element 8. So here I am asking whether it is a square matrix or not. I repeat definition of square matrix. A matrix is said to be square matrix if number of rows are equal to number of columns. Okay, so here how many rows are there? 1 row. How many columns are there? 1 column. Obviously here number of rows is equal to number of columns. Number of rows is equal to number of columns. Yes or no? So that here we say that this is also an example for square matrices. Order is 1 by 1. So here A, B, C are the square matrices of orders 3 by 3, 2 by 2, 1 by 1 respectively. Yes or no? So in square matrices, Instead of saying order 3 by 3, simply we say that order is 3. Here we say that order is 2. Here we say order is 1. So here A, B, C are the square matrices of order 3, 2, 1 respectively. Okay. Next. Diagonal elements. Not diagonal matrix. I am not discussing about diagonal matrix. That will come to later. Diagonal elements. So what do you mean by diagonal elements? Means in a square matrix, see here in this example, in this square matrix, the entries from the left top corner to the right of the bottom corner, elements means like this. The elements from left top corner to the right of the bottom corner called diagonal elements. Here 2, -2, 8 are called diagonal elements. Okay. So here what about remaining? Here 3, 4, 7, 1, 6, 9 are said to be non-diagonal elements. Non-diagonal elements. 2, -2, 8 are diagonal elements, whereas the rest of the elements 3, 4, 7, 1, 6, 9 said to be non-diagonal elements. Here you one notice that here this is the element, just to observe the position of element. This is A11. Yes or no? This is the position of A22. This is the position of A33. So diagonal elements are A11, A22, A33. Yes or no? So here this is the position of A11, A22, A33. So A11, A22, A33 diagonal elements. Okay. So here, whereas position of 3 is that is A12. Is it right? This is A13. This is A1. This is A21, A22, A23. This is A31, A32, A33. Don't make confusion. First suffix used for number of rows. Second suffix indicate the number of columns. Okay. See here. Then how do you define general matrix? So we define general matrix A is equal to Aij, that is M cross M. This is the general definition of square matrix. Okay, I hope all of you got it. Is it right? Next we move to the diagonal matrix. Diagonal matrix. So here diagonal matrix is another type of square matrix. It is a particular type of square matrix is said to be diagonal matrix. Got it here? See here. Diagonal matrix again a square matrix. You don't make confuse here. Okay. See here. I am going to write here. Consider the matrix like this. So So 2, 0, 0, 0, 3, 4, 0, 0, 5. This is example for square matrix. Yes or no? Okay. Next I take one more example, that is 5, 0, 0, 7. Yes or no? Again it is example for square matrix. You take one more example, that is 4 is also an example for square matrix. So now see here. Here what you can notice here, sorry, so this is you take it, sorry, this is you take it as 4, sorry, this is 0, okay, this is 0, this is 4. So this is a square matrix. Here what can you observe here? 2, 3, 4 diagonal elements. Remaining are non-diagonal elements. Such type of matrix we called a diagonal matrix. Means, how can you define here? Diagonal matrix is a square matrix. Okay, or square matrix is a diagonal matrix if non-diagonal elements are zeros. Okay, but it is not. A square matrix is said to be a diagonal matrix if its non-diagonal elements are zeros. This is the definition of diagonal matrix. Here also you can observe here, non-diagonal elements are zeros. Example for, then what about this one? Of course, this is square matrix. The definition says that a square matrix is said to be diagonal matrix if non-diagonal elements are zeros. Here non-diagonal elements are not available, means you leave it. But here diagonal elements is 4. Okay, this is also example for diagonal matrix. Okay, got it here. Now we define in general, let A is equal to Aij is said to be a diagonal matrix. Is said to be diagonal matrix. Yes or no? So this is, it should be, first of all, it should be square matrix. Therefore, number of rows and number of columns. Next, you have to say that here Aij's here. This is the position of A11, A22, A33. So I write like this: Aij, that is Aij equals 0, means this is the position of A12, A13. Means here, what is the position of this one? Position of this one is A1, A12. Here 1 is different from 2. Is it right? This is the position of A13. Here first suffix and suffix are different. Whereas in the case of diagonal elements, see here 1, 1, 2, 2, 3, 3. Here I, J are same. Got it or not? I, but in the case of non-diagonal elements, I and J are different. Therefore, non-diagonal elements A, I, J should be 0, where I is not equal to J. This is the definition of diagonal matrix. I hope all of you got it. Yes or no? Here, just observe here, in the diagonal elements, here both suffixes are same. 1, 1, 2, 2, 3, 3. Okay. So, in non-elements, this is the position of A12, A13 means here I and J are different. Here also same. A21 means 2 is different from 1. It's right. Okay. This is the definition of diagonal matrix. Next we come to the scalar matrix. We come to the scalar matrix. Definition of scalar matrix. Again here scalar matrix, here we say that Again, a scalar matrix is a specific type of square matrix. specific specific type particular type of square matrix is said to be scalar matrix. Okay, here diagonal, this is said to be a diagonal matrix. Yes or no? Here diagonal matrix, I take first example, I will write example, then you can understand. Here 2 0 0 0 2 0 0 0 2. Okay, this is an example for diagonal matrix as well as square matrix. Next, this is 5 0 0 5. This is diagonal matrix as well as square matrix. Next, you take 3. This is square matrix. This is a diagonal matrix as well as square matrix. Okay, then what do you notice here? Here diagonal elements are equal. Okay, sir? No. So this particular type of matrix we called as scalar matrix. So a diagonal matrix, of course, again this is all the example for diagonal matrix, because non-diagonal elements are zeros. Yes or no? Non-diagonal elements are zeros, and okay, so the hence it is said to be diagonal matrix. Okay, so here diagonal matrix is scalar matrix. If diagonal elements are what? Equal. That is the definition of scalar matrix. This is example for scalar matrix, because only one diagonal, we have only one element along the diagonal, hence is also considered as a scalar matrix. Okay, so now we define general definition. Let A is equal to Aij. First of all, it should be a square matrix. Okay, it is a scalar matrix when here Aij equals 0, means non-diagonal. Non-diagonal means suffixes are different. Okay, next Aij is equal to, it should be always same. I write it as K, that is I is equal to J. This is the general definition of scalar matrix. Okay, next we come to the last definition, that is identity. Two more types are there: identity matrix and zero matrix. Next one is identity matrix or unit matrix. It is denoted by I. Again, it is a identity matrix is a particular type of square matrix. Let us we consider example 1 0 0 0 1 0 0 0 1 0 0 1. This is a square matrix, diagonal matrix, and also scalar matrix. Yes or no? Next, you take one more example, 1 0 0 1. This example for square matrix, diagonal matrix, scalar matrix. Again, here we can observe that we notice that some again are particularly different from diagonal matrix, scalar matrix. That you have to notice here. So here diagonal elements are 1 1 1. Okay, so whereas here, see here, in the diagonal matrix, diagonal elements, now only the non-diagonal elements are zeros. Yes or no? Whereas in scalar matrix, non-diagonal elements are zeros, but here diagonal elements are equal. So here non-diagonal elements are again 0 and diagonal elements are equal but it is unity. Such type of matrix said to be identity matrix. Got it here? So this is an example for identity matrix. Then how do you define here? Here we define a identity matrix means it is a square matrix, or we call it as a scalar matrix is said to be identity matrix, in which diagonal elements are unity. Diagonal elements are unity is said to be identity matrix, usually denoted by letter I. Again here only one element. This is also example for example. This one is example for identity matrix. So here let us see how we define generally how do we define identity matrix. First of all, it should be a square matrix, means its order m rows and m columns should be same. Okay, and it is said to be a identity matrix if Aij means Aij equal non-diagonal elements are zeros, means when I is not equal to 0, such all the elements should be zeros. Next, Aij should be 1 when here diagonal element. In diagonal elements here both suffixes are same. This is the general definition of identity matrix. Now let us see the last type is that is zero matrix or null matrix or void matrix. Zero matrix, null matrix or void matrix. Here definition is very quite simple. A matrix is said to be zero matrix. A matrix is said to be zero matrix if all its elements are 0. Put it here. I consider 0, 0, 0, zeros. Okay, this is an example for zero matrix because all the elements are 0. You take one more example. Again, this is a row matrix which all the elements are zeros. Next, you take one more example. So this is a column matrix. Column matrix in which all the elements are 0. Yes or no? Here, next you take one more example, that is only one element 0. This is also zero matrix. Means a matrix is said to be zero matrix if all its elements are 0. Okay, so here it is denoted by usually the zero matrix or null matrix and void matrix are used denoted by O, letter O. Got it here? So here this is the definition of zero matrix or null matrix or void matrix. So here in today's class we have discussed definition of matrix and types of matrices. Okay, I hope all of you got it. Yes or no? If you have any doubt, you can comment. Okay, so in the next class we shall discuss algebra of matrices. Algebra of matrices means how to add up the matrices, addition of matrices, subtraction of matrices, scalar multiplication of matrices. Okay, okay. And in the next class, we shall discuss algebra of matrices and some examples. Okay, please, please share. Please, those who are not subscribed, please subscribe my channel and share your friends. Okay, thank you for watching.